Hello students, welcome to the next lecture on the vector subspace. Today I will explain you 25 more examples related to how you can check about the vector subspace. Myself Dr. Harish Garg. You can follow my YouTube channel where you can find the various lecture on the mathematics 2. That playlist is available in this tab. Now what is the objective of this lecture is we will see any of the non-empty subset W is said to be the subspace if and only if this property hold. That means what does it mean? If you have the subset W, you can take any of the 2 point U and V, fine. Or firstly you can see, otherwise if I say any of this subset W, take the 2 point U and the V, then take any 2 point from the set, then the sum of them is also the part of this W, and when you multiply with the alpha, where alpha is the any real number, then is also the part of this W. Make sure third property, that is a 0, is also the part of this W. That's meaning of the non-empty subset. How you can prove that whether it's a subspace or not? So that means there are the two ways. The first way is how you can prove that it's a subspace, and second is how you can disprove that it's a subspace. A very simple approach I will tell you. Whenever you want to show that W is a subspace, you have to satisfy these three properties. That means you can choose any 2 points from the set and prove that the sum, linear combination and the 0 is also a part of same. Make sure alpha is the part of the real number. Alpha can be the root 3, alpha can be minus 1 over 3, it can be 4, it can be 9 over 3 or 9 over 31 and so on. How you can prove that it is not a subspace? You have to provide one counter example so that this property is not satisfied. In most of the cases, this property will work to check whether it's not a satisfied. I hope you can subscribe my YouTube channel to learn many shortcut tricks. In this lecture, I will explain you with the help of the 25 examples where. So let's start with this one. What is the rule behind that? Make sure whatever the set is given to you, your first target is to check whether the 0 is the part of this or not. How you can prove? First you can see it's R2. What is the 0 element of the R2? 0, 0. Fine. Now you have think about this set. Now check whether this is my X, this is my Y, whether this will satisfy the given requirement or not. Now you can see 0 and 0, X is the, because 0 is the part of the integer, so yes, this satisfied. So therefore you can see your first property, 0 belongs to the S, will satisfy. You can write your examination like this. So since 0, 0 is a part of the R2 and X, Y is the part of the Z, so therefore 0 is the this one. Oh sorry, 0 is the part of S. So first property satisfied. Now always look about the third property. Firstly, choose any U. What is the U is? X, Y. You may choose U as a 1, 2. You may choose U as a 3, minus 4. Fine. But make sure X and Y are integer. But make sure you can never choose the U as this number, because 1 over 2 is not the part of Z. So you can choose any of the U. Can you think about the alpha? Can you think about alpha, so that when you multiply them, it is not an integer? So if you choose alpha is my root 2, then what will be my alpha into U? Fine. What is my alpha into U? That's a root 2 and 2 into root 2. Now check whether this will satisfy this property. This is my X, this is my Y. Clearly say they are not my integers. Fine. So what does it mean? That means this is not the part of the S. So if one of the property is not satisfied, you can say it is my not subspace. Look at this second property. Again it's a part of the R2. So let's start with the 0. So since 0 is, now this is X and Y, these are the real numbers satisfied. There is one more property. Now you can see whether this property is satisfied. Is it satisfied? No. So it means 0 is not belongs to the S. So once 0 is not belongs to the S, it means it is not a subspace. You have to make sure any one of the property not satisfied, it is not a subspace. Now again it's R2. I can start from the 0. So 0 comma 0 is the part of the R2. Check whether this property is satisfied. 0 square plus 0 square is less than or equal to 1. Satisfied. Therefore 0 is belongs to the S. Fine. Now you can choose any of the U which satisfied this property. You can choose U as a 1 comma 0. You may choose U as a 1 comma 2 1 comma 2 because it's a 1 over 4 plus 1 over 4 is 0.5 satisfied. You can choose any number U. So I choose U is my this. You can choose alpha. So say alpha will be my 5. Fine. What will be my alpha into U? So that's a 5 comma 0. So does it satisfied this property? X square plus y square is not less than or equal to 1. So what does it mean? If it not satisfied, that means alpha U is not the part of S. So this property not satisfied, hence it is not a subspace. Look at this one. This is the x cube. So I have to think the 3r cube. Does it satisfy property? 0 square, 0 square, 0 square less than or equal to 1 satisfied. Therefore 0 is the part of S. You can choose any of the U which satisfied this property. So I can choose 1 0 0, or you can choose as a 0 half. This is also satisfied, and you can choose any one which satisfied this property. Now you can choose any of the alpha. Again I can choose alpha is 5. Then what will be your alpha into U? 5 0 0. Fine. You may choose alpha as a 3 also. It's on your choice. Then your alpha U will be 3 0 0. Does it satisfy this property? Now you can see as 5 square plus 0 square plus 0 square is not equal to less than or equal to 1. So therefore alpha U is not the part of the S. Similarly, if you think about this, then you can see 9 plus 0 is not less than or equal to 1. So therefore it is not a subspace. Okay, again it's R cube. I can choose a 0 element firstly. 0 is the part of the R cube. Now check whether this will satisfy the given requirement. 0 plus 0 minus 0 is equal to 3. Not satisfied. So if it is not satisfied, 0 is not the part of S. Hence it is not a subspace. Look at this one. If I choose 0, this is the part of R cube. Now the only requirement is x3, this component. x3 is greater than or equal to 0. Yes, equality is satisfied. So therefore 0 is the part of S. Now you can choose any of the U, because you can see your requirement is only for the x3. x3 should be positive. x1 and x2 can be any number. So it can be -1, it can be 4, fine. Or you can choose any of the x1, any of the x2, but x3 should be positive. Fine. So you can choose any number. Can you choose any of the alpha, so that alpha U will be, this property will not satisfy. If I choose alpha is my -2, then it will be -4. So clearly say x3 as -3 is not greater than or equal to 0. Therefore alpha into U is not the part of the S. Hence it is not a subspace. Remember, one counter example is enough to disprove that. Okay, P is a subspace. Coefficient of the x cube is 3. Again, so let's say I can choose a polynomial is f1x, just like say U, such that the coefficient of the x square is my 3. So I can choose say x cube, because degree of polynomial is not given. So I can choose as x square plus say 1. Fine, it is a satisfied this property. If I choose f2 is another polynomial, which is say my x cube, say minus of 3x square plus x. Again it satisfied this property. Then what is my f1 plus f2x? It is my 2x cube plus x plus 1. Does it satisfy this property? No, because this statement suggested you the coefficient of x square is 3 or -3. But what is the coefficient of the x3 in this case? 0. It is not satisfied. therefore it is not a subspace. There is one more example, one more way. You can choose any of the f1. Choose alpha will be say 2. Then what is my alpha of f1? 2x cube minus 6x square plus of 2. Or you can choose any of the alpha. Clearly say the coefficient of the x square is not 3 or minus 3. So that means this is not the part of S, hence not a subspace. Again, is a R cube. This is the element of the R cube. Now clearly say x into y. The first element x, the product satisfied. So 0 is the part of S. You can choose any of the two number. Say u is my 1, 0, 1. It satisfied this number. Or 0, 1, 4. Again it satisfied this number. What is my u plus v? 1. This is the part of the S. This is the part of the S. If you add them, does it satisfy this property? X into y is not the part of the S. It means it is not a subspace. Fine. Or you can choose any example. I have chosen 1, 0, 1, 0, 1, 4. You can choose any other example as well. So clearly say u plus v, this x into y is not 0. It is not a subspace. Again you can see the set of all those polynomial. Degree is not given to you. Collection of all those s whose degree is my 4. Firstly 0. I can write the 0 polynomial as this form, x square plus 0. So therefore degree of the polynomial is 0 is my s. Or I can choose u, or this is a polynomial, I can say is a p1x. Any of the polynomial of degree 4, x4 plus 1. I can choose another polynomial of degree 4, x4 plus x. Fine. This is a part of the S. This is the part of the S. But if you add them, what will happen? Is the degree is 4? Because he said equality 4. It is not satisfied because the degree is my 2. Or you can choose either this example or this example. Again, degree is not equal to 4. It is not subspace. You can choose any of the example. I have chosen this. If you add them, the degree is my 2, which is not equal to 4. It is not a subspace. Again, you need to choose a polynomial of degree greater than or equal to 5. So I can choose this number x5 plus 1, or second polynomial is minus x5 plus x. Both satisfy this condition. Then what is the polynomial? p1x plus p2x. It is 1 plus x. What is the degree of this polynomial? 1, which is not greater than equal to 5. So it means it is not subspace. Or you can choose any other example like x6 plus 1 and so on. If you add them, again clearly say the degree is my 2, which is not greater than 5. It is not a subspace. Now, so again, firstly you can choose as a 0, which is a part of the R2. Now y, this is my y, 3 times x. Yes, it's satisfied. Fine. So therefore 0 is the part of R. Okay. Now how you can prove that it's a subspace? Remember, so I can choose, you can see that alpha of u is also satisfied. There is no issue because you can never choose any, there is no counter example. So I can choose any of, because the pair is my x comma y. So let's say u is my x1 y1 and v is my x2 y2 is the part of s. What does it mean? If this will satisfy this property, that means y1 is equal to 3x1 and y2 is equal to 3x2. Then your target is to prove sum of them is belongs and alpha into u is also the part. So your target, then what is my u plus v? x1 plus x2 plus y1 plus y2. Then your target is to prove u plus v is the part of s. So for this, what we need to prove? We need to prove y is equal to 3x. What is the y? y1 plus y2 is 3 times of this. So I can start from the left hand side. What is the value of y1? 3x1. What is the value of y2? 3x2. Clearly say if I take 3 as a common, you will get this required result. So therefore u plus v belongs to the S. Second property, I can choose alpha belongs to the R. Therefore alpha u is my this. Your target is to prove alpha u belongs to the R. That means this is my y, this is my x. I can start from the left hand side. What is the value of the y1? 3x1. I can return 3 is outside, alpha x1. So clearly say this satisfied this property, hence alpha u is also the part of S. So we have satisfied all these three properties. 0 belongs to the S, u plus v belongs to the S, alpha of u belongs to the S. Hence S is my subspace. Make sure student remember always remember, if you prove that it is not a subspace, then one counter example enough. But if you prove that is a subspace, you have to taken u as the pair of x1, y1 and so on. You can never consider u is my say 1, 3 or v is my say 2, 6. If you want to prove a subspace, you have to consider x1, y1 and so on. Look at this another one. Check whether 0 is R2. Whether 0 satisfied or not. So clearly say 0 plus 0 is 0 satisfied. Fine. Now let's say u is x1, y1 and v is my x2, y2. Now we have to prove that it's a subspace. I have to consider this one. What does it mean? x1 plus y1 is 0 and x2 plus y2 0. Then I can take u plus v. U plus v will be my this quantity. Then your target is to prove this number will be satisfied and this number will be satisfied. Or you can firstly, before start of them, you can think, can you find the value of alpha so that this property is not satisfied? It is always satisfied because it's a linear nature. Fine. Now your target is to this. I can start from the left hand side, x1 plus x2 plus y1 plus y2. I can find the value of x1 minus y1, x2 is minus y2 plus y1 plus y2. So it's a 0. So if satisfied, therefore u plus v will satisfy this S. Next I can take alpha is the R. Then what will be your target is x plus y is 0. I can start from the left hand side. Again I have to substitute the value of the x1 and this number. Clearly say it's 0. It's satisfied. Therefore alpha u is the part of S. Hence all these three properties satisfied. First one, this property, and u plus v belongs to the S. Therefore S is my subspace. Now look at this one. Firstly you can check about the 0. 0, 0, 0 is a part of R cube. So clearly say 0 plus 0 plus 0 is greater than or equal to 0. Equality there satisfied. Always remember, whenever there is a form of the some equation or inequality, always try to prove the counter example. Now say u, you can choose any of the u which satisfied the sum of them greater than 0. I can choose this number, sum is my greater than 0, or remember this suggested you the sum will be greater than 0. So you may choose this is minus 1, this is a minus 2. So I can choose this number is my 4, so that the sum will be greater than 0, or you can choose any of the number. So let's say, always remember in your examination you have to satisfy the 0 property also. Now can you choose alpha of any number? If I choose alpha is my minus 2, then what will be my minus alpha u? Minus 2, minus 6, minus 4. Does it satisfy this property? Now S minus 2, minus 6, minus 4, does it not satisfied greater than 0? Therefore this is not a subspace. Look at this one. Always satisfied firstly 0 property. 0 is the part of R square. Now does it satisfied? 0 over 0 is equal to 1. Not possible. Why? Because 0 over 0 is my undefined. So if this does not satisfy, it means 0 is not the part of S. So once 0 is not the part of the S, it means one property is not satisfied, it is not a subspace. Okay, P is a subspace of all the polynomial. Again, degree is not given. So firstly, 0 polynomial. This is the 0 polynomial. I can written as a 0x cube, 0x square and 0x plus 0. So clearly say, what is F0? F0 is 0. What is F1? 0. So clearly say 0 is equal to 0. Therefore 0 satisfied S. Fine. Now because they are satisfied as equality, so that means this is generally a subspace. So I have to prove is a general definition. Because it's a function of the fx, I can take, instead of the u and v, I take f1 and f2 is the part of S. Fine. If f1 and f2 is the part of the S, what does it mean? f1 will satisfy this property, f1 0 is f1 of 1, and f2 is also satisfied this property. Then what is your target? Your target is to prove f1 plus f2 is also the part of the S. For this, I need to prove twice of this must be f1 plus f2 1. So let's start with the left hand side. Fine. So I can return this number is twice f1 0 plus f2 0. Now you can open this bracket, twice of f1 0 plus twice of this. I can substitute the value of twice of f1 0, f1. Fine. Plus f2. Now I can return this number is again f1 plus f2 of 1. So this property satisfied, hence f1 plus f2 belongs to the S. Now for the third property, you can choose alpha is the part of this. Then what is my alpha of f1? Your target is to prove, if I choose alpha belongs to the R, then your target is to prove alpha f1 belongs to the S. That means this property. I can choose, start from the left hand side. So this number I can written as 2 alpha f1 0. What is the twice of f1? It is alpha times f1 of 1, and you can see this is my same number of this quantity. So therefore this is my vector, this is my subspace, because all these three properties satisfy. Okay, it's R cube 0 0 0. Fine. Does it satisfy this property? What is the x1? This is my x1. What is the x3? This is my x3. Is it satisfied? Yes, 0 is equal to 0, satisfied. Fine. Now again you can see it's a equality, so it's generally a subspace. We will try to prove that. So let's u is x1, x2 and x3, which belongs to the S. V is my y1, y2, y3 is the part of the S. So what does it mean? If u belongs to the S, it means root 2 x1 is root 3 x3, and what is the y belongs to? Root 2 y1 is root 3 y3. Fine. This is given to you. Then your target is to find the u plus v. So what is the u plus v? So u plus v will be x1 plus y1, x2 plus y2, x3 plus y3. What is your target? Your target is to prove this number. So for this, what you need to prove? You need to prove is root 2 times x1. What is the x1 of the u plus v? x1 plus y1 is root 3 x3 plus y3. This is your target. So again, a very simple, I can start from the left hand side. Fine. I can open this bracket. I can substitute the value of the root 2 of x1 and root 3 of y3, and you can see it is my satisfied. Third property, I can choose alpha is belongs to the R, then alpha u will be alpha x1, alpha x2, alpha x3. What is your target? Is to prove root 2 of x1 and root 3 of. So again, I can start from the left hand side. I can return this number is my this manner. What is the value of the root 2 x1 is a root 3 x3, and you can see these are my same numbers. Therefore, all these properties satisfied, hence it is my subspace. Let P is the subspace of all the polynomials. Then again, firstly check for the 0. Can you return 0 in the form of this? What is the requirement? Your requirement is only the coefficient of the x square is real. You can see 0 is the part of the R. So therefore 0 belongs to the S. Fine. Now I can choose the two polynomials. P1x is ax square and P2x is bx square, and both are the part of the S. So if both are the part of the S, what does it mean? Coefficient of x square a is belongs to the R, and coefficient of b is also the part of the R. Fine. Then your target is to prove P1 plus P2, that's a u plus v. Now what is your target? Your target is to prove the coefficient of the x square a plus b is the part of the R, and that's very simple. Now you can see a and b are the part of the R. That implies a plus b is also the real number, hence this is my belongs to the S. Now I can choose alpha belongs to the R. Then what is the value of this in ax square? That is my alpha into a x square. Then what is your target? Your target is to prove alpha into P1 is the belongs to the S. So for this, what you need to prove? So we need to prove only alpha times a, that is the coefficient of the x square, is my real number. Now again it's a very simple, because alpha is my real. What is the a? A is my also real numbers. So the product of the two real number is again a real number. So therefore this is also satisfied. Now you can see the P1 plus P2, 0 is also already satisfied, scalar product also satisfied, hence it is my subspace. Okay, P3 is the polynomial of degree at most 3. Now in this case the degree is given to you. So firstly, can you write the polynomial of degree 3? A plus bx plus c x square and so on. I need to find the derivative. So can you find the derivative? I need to find the derivative at the point 1 is 0. So what is the value of this? That will give you b plus 2c plus 3d is equal to 0. I can substitute all these values in my given S. Fx, this number, f dash 1, this number. Fine. From this case, I can find the value of the b minus 2c minus d. I can substitute the value of the b at this point. So that comes to be this number. The condition is all those a, b, c, d are my real number. Also, I can write the coefficient a, then the coefficient of the c, and the coefficient of the d, which comes to be this number. Fine. Now your target is to make proof this S belongs to the subspace or not. So firstly, I can start from the 0 polynomial. So 0, I can write as a 0 of this plus 0 of this. Now the only requirement you needed to check is the coefficient of this a, c, d are my real. So clearly say 0 is my real. So therefore 0 polynomial belongs to the S. In this case there is no b, so there is no need to think about the b. Now take two polynomials, f1x, f2x. What is my f1x is? I can write as a1 plus c1 of x square minus 2x plus d1 of x cube minus 3x. Similarly for this, a2 plus c2 and so on. That means because there is no B involved, so that means A1, C1 and D1 is the part of the R, and A2, C2 and D2 is the part of R. Then your target is to prove F1 plus F2 is also a part of S. So firstly you can find what is the value of the F1 plus F2. So your target is to prove the coefficient of this is the part of the R, this is the part of R, this is the part of R. Now that you can easily write that, because A1 and A2 is the part of R, this implies A1 plus A2 is the R. Similarly for C1 and C2. Fine. So therefore F1 plus F2 is the part of S. Similarly, if I take alpha is the R, then I can multiply this value with the alpha, you will get this. Your target is to prove this number is my R. Fine. Because alpha is in the R, A1 and C1 is R, so therefore this number is also the S. Hence it is my subspace. Let P is the polynomial such that having negative coefficients. You can choose any of the polynomial, degree is not mentioned, but the coefficients are my negative, like minus x square minus 1. All the coefficients are negative. Fine. Now if I choose any of the alpha, can you choose the alpha? If I choose alpha is my minus 2, then what is my alpha into F1? 2x square plus 2. Does it satisfy this property? Coefficient of the x, coefficient constant, these are not my negative numbers, hence it is not my subspace. Again it's R3. Firstly you can see about whether 0, 0, 0 satisfied or not. So that is y is, yes, it's satisfied. Fine. If it is not satisfied, you can directly write it is not a subspace. Now you can choose any of the u, y and z square. If I choose z is my 2, then y will be my 4, and there is no condition on the x can be any number. Fine. Or if you choose z is my 1, then y will be 1, x can be any number. I can choose minus 4. Fine. I can choose u is my this. Now if I choose alpha will be any number, say 2, or you can choose alpha will be my minus of 3, that's on your choice. Then what will be my alpha u? This number. Does it satisfy this property? This is my y, this is my z. Now as 8, is it satisfied? No. So therefore alpha u is not the part of S. Hence S is not the part of subspace. I hope you can like my video. If you feel that it is a very useful, you can put a comment on the chat box. Again it's a polynomial of degree 3, subspace or not. Again you can see, if I take a 0 polynomial, then f of 0 is also 0, f of 5 is also 0. That's a satisfied. Fine. So let's say f1 and f2 are the part of S. That means f1 of 2 is 0 and f1 of 5 0. Similarly for the f2 of 2 0 and f2 5 0. Your target is to prove this number. I can start from the left hand side. If you open this bracket, this number is my 0, this is 0, hence. Similarly if I open this bracket, it is f1 5, it is f2 5, f1 5 is my 0, f2 5 0, this is 0. Both the conditions satisfied, hence f1 plus f2 belongs to the S. Third property, if I choose alpha is the R, then what will be your target? Your target is to prove alpha f1 belongs to the S. That means your target is to prove alpha f1 of 2 and alpha f1 of 5. I can start from the left hand side. Fine. So again I can return this number is f1 of 2. What is the f1 of 2? 0. So alpha into 0 is my 0. Similarly you can prove that alpha f1 5 is also 0. All these three properties satisfied, hence it is my subspace. Make sure student, in the examination you have to prove that 0 is the part of the S. Again this is a similar one. Fine. because you can see 0 is a polynomial satisfied. You have to write this case in the examination for the each examples. Let P1 and P2 are the two polynomials in the S which satisfied this. Then your target is to prove P1 plus P2. I can start from the left hand side. I can open this bracket, you can see will be satisfied. Look at the second case. If alpha belongs to this, I can start from this. If I open this bracket, it's a P1 0, P1 of 1. We need to find the P1 at the 1. I can check it. Yes, P1 of 1. So I need to check at a P1 of 1. So what is the P1 of 1? P1 of 1 will be 0. So alpha into 0 is a 0. It's satisfied. Hence, alpha into P1 is a part of S. All these three properties satisfied. Therefore, it is a subspace. I hope you can like and share my videos with your friends. We will see the next lecture on the linear span and the linear combinations. Till then, you can share this video with your friends. Best of luck, students. Happy luck.